Welcome to Deconversations, a rather excellent podcast if you're listening, and a webinar if you're watching, discussing all things related to medical devices decontamination. Brought to you by Dan Cole, the instrument maker, Matthew Pescott, entrepreneur and former sterile services manager, and Pawel Sternberg-Stylovsky, a research and development engineer. This episode begins with the subject of ultrasonics.
This afternoon we've chosen to talk around the subject of ultrasonics and ultrasonics in washing and a sterile services environment. It's something from my perspective is of interest from a surgical instruments point of view in relation to design of instruments. And I'm just going to pick up with Pawel first of all, with a bit of a look at shadowing and how that affects the issues and how that can be overcome through ultrasonics.
Hi, everyone. In terms of shadowing in ultrasonic washers or in cleaning systems in general, we are talking about a phenomenon where we are somehow impeding the mechanical force that normally is responsible for removing contamination from surfaces of instruments, and we are somehow blocking access of that mechanical energy. So in washer disinfectors, this is going to be caused by blocking the path of the jets that come from the spray arm. So the mechanical energy of water coming out of spray arms is not actually reaching particular parts of instruments, and they are usually impeded by other instruments, elements of other loads, sometimes baskets themselves. So it's a very complex problem. In ultrasonic washers, it's a slightly different scenario, because in ultrasonic washers, we are depending on ultrasonic energy being delivered to the surface of instruments, and in this particular case, it's large surfaces that will deflect ultrasonic waves that cause cavitation near the instruments and remove contamination. So anything that is physically blocking or reflecting waves, ultrasonic waves from transducers is going to cause shadowing. In ultrasonic washers, this is, I would say, a less prominent problem in comparison to washer disinfectors, because with washer disinfectors, as soon as we have an element of the instrument blocking the sprays, there is really very little water accessing particular parts of the other instrument that is shadowed. But in ultrasonic washers, this is more complex, because we also have reflections of ultrasonic waves. So one way or another, we are going to maybe diminish or lower down the power of cavitation created around the instrument, but it's not necessarily going to completely cut us off from cavitation and from ultrasonic waves accessing instruments within the volume. The one caveat is that ultrasonic cleaning is only going to clean those surfaces that are in direct contact with the medium. So instruments needs to be, first of all, fully submerged in water, and when we have instruments that have cavities, holes, we also have to make sure that water penetrates those cavities entirely, and there are no air bubbles trapped inside of instruments, because that is one of the scenarios where this ultrasonic energy would not simply reach the surface. Is that clear?
Yeah, I mean, I was just looking at obviously the challenges that we have with instrumentation, and thinking back to last year when we were working on a project where we had very, very complex cardiothoracic instruments, and there were like over 100 in the set in one tray, and I really looked at it and thinking, how can you really guarantee that in the washer disinfector situation, first of all, that obviously you're going to get shadowing. And Matthew, with that sort of volume in a tray of instruments, is there a sort of set protocol of how to first of all organize that? Obviously we have instrument pins and things like that, but would it be that it's a balance, sort of, Matthew, to the both of you, a balance of using ultrasonics where necessary on the more intricate instruments, but better organisation in the trays overall? What's your thoughts, Matthew?
I think the problem is that over the years, I mean, back in the day, we used to have like sort of tunnel washers, which were like batch washers. So basically, you'd have one tray going in after the other. So they were basically continuously going through, and that you would just have a single layer on a large tray that would be sent through. So although you couldn't validate these washers, and they were catering washers that have been adapted for cleaning instruments, they were actually pretty good cleaners. So what happened is it evolved into a dishwasher, like a domestic dishwasher type scenario, where you had these upright washers with several levels. I think personally what's happened is that instead of the washer disinfector manufacturers giving the customers what they need, they've given them what they've wanted. So they've demanded shorter cycles. They've demanded to be able to increase the capacity. So you have these 15 DIN machines, which, to be honest with you, are not really fit for purpose. Then the next problem you've got is the pressure of turning trays around, and some units don't like splitting trays. They don't like dividing trays. So like you were saying earlier, you could have a tray going through with 100 instruments and like 2 or 3 layers or more. And with the best will in the world and the best detergent and the best mechanical action, you're just not going to get those instruments clean. So my view is that with the 100 instrument scenario, maybe it's the instrument manufacturers that need to write the IFUs to make it perfectly clear that if the SSD manager is not willing to sort of thin the set out over 2 or 3 trays, that there should be an ultrasonic process before the washer disinfector process, which has been borne out by Mark Campbell and the studies he's done.
Yeah, I read that yesterday. Actually, I thought I listened to Mark's podcast through Beyond Clean yesterday, and I thought it's really. I think the research that's done, the initial research, it's very hard to get away from the fact of the impact that the ultrasonic has, isn't it, Pawel? I think that. I know you're a big advocate for ultrasonics, and we use them in the an industrial perspective, and I don't know how you could not use them, because obviously we have the intricacies of manufacturing debris and grease, and there's no possible way that you would really get these items clean without fairly heavy duty manually cleaning if it wasn't for the use of ultrasonics. So it seems to me that the future should be going back towards a more all-encompassing process, including ultrasonics, where it would be see fit that it be needed.
I think that in the case of development of cleaning processes, what really needs to be understood over here is that the geometry of the instruments and the complexity of the instruments really makes it a different challenge from one set to another. So, we've been toying with an idea that you can have this one wonderful process that is going to clean stuff, but that's really not realistic in terms of application, because Dan, from the perspective of the manufacturer, how very different classes of instruments are in terms of not only size but also the intricacy of detail, particular elements of that load that create those traps for contamination. So if we are talking about any crevices, any mechanisms, box joints, clamps, any instruments that have manufacturing marks or elements that are used to assemble them, so interlocking components, those actually create different scenarios for our washing process. And whenever we are talking about instruments, I consider complex instrument anything that that has more than one component on its own. So every time when we consider those particular instruments, we really have to adapt our cleaning process to the outcome. And unfortunately, the only way to verify that we are going in the right direction is to measure the result. Because at the moment, imagine what we are doing and what we've been doing historically is you have this 1 year or maybe now quarterly even event of validation of the equipment. So you do your test soil run, you make sure that you select, let's call it a representative set of instruments, and then you assume that everything that goes through that washer after validation before the next one is going to come out with exactly the same outcome. And that, unfortunately, is not the case because the sheer differences between instruments. So measurement of contamination after the process is a must. And then one way of accessing the sort of complexity of process design is to actually evaluate different types of instruments and see to what extent the results differ. And also, I would say, try different regimes or different loading patterns to see how much they affect the final result, because you'll be able to very quickly evaluate if the baskets loaded to the machine contain as you said, hundreds of instruments, then what effect it has on the final outcome. And by measuring the results, you'll be able to verify whether that process is effective and whether there's something that you need to do with it. Ultrasonics is a fantastic solution for those complex instruments and very heavy loads. And then you can actually incorporate it to the full process to see how you can improve that. But there is no one silver bullet that is going to automatically change the outcome. This is something that, with the knowledge of the instruments that you routinely reprocess, you'll be able to find out what will work best for you, and then you optimize your processes to your particular machines, to your particular chemicals, and by measuring the outcome, you'll be able to verify that you've done it right.
Yeah, because I picked up that the current standard, which includes validation direction on the different features of instrumentation, has obviously increased in terms of the different challenges they're looking at for the different fixations of each instrument, and lumens and but I think maybe it's a matter of moving beyond that and also looking at things like the surface finish of the instruments as well, because I'm wondering if that's a factor. From Mark, we mentioned Mark Campbell, his research he's done, if there's any variation in things like the surface finish and how that's been affected through the loads he's been using.
Well, I was very interested in that study that you started, Daniel, with regards to instrument coatings. That just sort of seemed the way ahead. To find a way to make the stainless almost like Teflon, so that if any soil tried to sort of attach itself to the surface or dry to the surface, it could be washed off very easily. I mean, it just would have so many additional benefits in the amount of chemistry you would need to use, the length of wash cycles. It would just improve the process so much. So I think moving forward, the design of the instrument is important, and how easy it is to be cleaned. I mean, we have lots of examples of surgical instruments that have been designed, in some views poorly, because nobody is consulted with anybody in decontamination to see how exactly you're going to clean it. It's like the robotic instruments that are now on the market. I mean, why they can't be taken apart, it just dumbfounds me, because there are a lot of laparoscopic instrument companies that have actually listened to the decontamination experts, and they now are designing laparoscopic instruments that can be taken apart. So it is possible to do that, and I can't see why that can't be done with robotics. And it's probably the most difficult and painful product instrument on the market for cleaning.
I mean, I think there's always going to be challenges, but it seems to me that the more expensive instruments, such as the laparoscopic stuff, there's been the investment in how to, these unique systems of how to take instruments apart completely and put them back together again. And quite often the lower end instruments, your sort of Rampleys and your Spencer Wells that might be under sort of £20 mark, that the acceptance is that is the way the design is. So therefore you've got, you have to deal with it really. And I suppose arguably in some of those instruments, the risks might be lower. They're not, maybe necessarily being used as invasively, but I think we should be looking now, especially in light of COVID-19, that I think there's been a bit of a flippant attitude to spending money on instrumentation and investing in it. Things like the coatings. I mean, that's perhaps not been something that will get taken up because of cost, but now we're seeing a potential new age of investment for the NHS, because we've been caught short in terms of investment and stocks put aside for coping with COVID-19. Will that have a knock on that will, I'm not saying will turn out to be an investment in new instruments, but at least it might shine a light on the fact that there are some of these areas that need looking at.
The problem is that you still have the existing stock in hospitals, and unfortunately, they still have to be cleaned. So this is it's definitely a good thing to think forward and get the message across to instrument manufacturers to consider decontamination as an integral part of the process of development of instrumentation. But unfortunately, we have quite a lot of instruments that are sometimes nearly impossible to clean that are already there, and we have to make sure that there is a lot of attention put towards actually considering which instruments can be difficult and which instruments will require a slightly more complex process to get them clean to the level that we need to be at. And one of the elements that we have to consider at the end of the day is we started with discussing whether we need to clean with ultrasonics or not, and wherever possible, the scrutiny of the entire process should give us this answer, because you will then find out whether a particular type or class of instruments needs to go through one process or the other. One thing that I still remember, and I'm hoping that we'll never get back to this situation again, is that washers and vectors were sold with two programs, a fast one and a long one. So this is one of the things that it wasn't the case of properly developing the process. It was just a case of saying you have a piece of equipment that's supposed to clean your instruments, but you don't really care whether they come out clean or not. So this is, we are coming back to the question is, how do you make sure that all the different types of instruments that go through the department get the same level of attention, and that they get sufficiently cleaned at the end?
Because I've just been thinking of that point, Pawel. And if I'm going through a process of validating a new device that I'm going to bring to the market, where you look at what what are the norms and the processes out there, and obviously washer disinfector and then standard sterilization cycle. But I think for a manufacturer to put in that they required ultrasonic cleaning as part of that process would obviously be a good step, but would that then alienate that device from getting rolled out into the market if it's not commonplace to have ultrasonics available?
I think that, to be honest, I think that we are looking at this from a slightly wrong perspective, because as a manufacturer, you cannot assume ad hoc what type of equipment people are going to use to decontaminate those instruments. And I think there's a huge danger over here of saying, oh, you have to put that in an ultrasonic washer for 20 minutes. And that the question is then 20 minutes at what power density, what type of ultrasonic system is that? What chemicals are you using in the process? And you just multiply the number of variables that someone needs to consider. And from the perspective of an instrument maker, this is nearly an impossible task. Therefore, the simplest way would be to say the responsibility on developing cycles would lie on people who actually go and clean them in situ, provided they have a method of evaluating after the process whether they've actually done the job properly or not. Because with ultrasonics only, this is treated as one part of the process. What about the manual preparation? We've mentioned the fact that some instruments need to be dismantled. Does it also mean that they have to be orientated in a specific way for efficient cleaning, whether in ultrasonic cleaner or later on in washer disinfector? So there's a whole cascade of problems over here, and we've been using Da Vinci as an example of super complex instruments. In their case, they actually went through the trouble of developing a unique process, but the instruments themselves, they are very similar in terms of their construction. Okay, you have different types of endorist tip that becomes that comes in different shapes and forms, but the instrument itself is fairly standardized in terms of the housing, in terms of how it looks. So from that perspective, it is probably a lot more convenient to develop a cycle or process that in this particular case is fairly complex, because you know that you can repeat it because the instruments are fairly similar. But if you have completely different types of instruments, and you cannot get to a situation that for every type of instrument you are going to have an entirely different instruction for use, because nobody is going to implement it in the field. Therefore, what needs to be done is, in the field, on site, someone needs to actually categorize those instruments, look at what challenges you've got, and then come up with a test protocol and a cycle profile for both the ultrasonic washer and the washer disinfector that are going to give you combined the outcome that you're after.
Okay. Well, so there we go. So it sounds like they're probably the answer isn't going to lie with a manufacturer of the instruments or the machines, but almost a collaborative approach locally at the site level. Yeah,
I do believe that the manufacturer of the washer and the manufacturer of the instruments does have an obligation to give the sterile services a sort of a starting point. Pawel was saying about, you can't have, you can't be too specific, but you can say that we recommend that because of the intricacy of the instrument, we do recommend an ultrasonic process. You don't have to be specific with times, temperatures, and detergents. You can specify, a maximum and a minimum temperature possibly, and a maximum and a minimum time but that would be the degradation of your medical device. That wouldn't be to do with its, its ability to be cleaned. That is the responsibility of the sterile services department to validate that process and establish that process. So as long as the instrument manufacturer and the washer manufacturer can give sort of fairly sort of to and froms, and a starting point that a manager can build upon. So so don't use a detergent with a pH of over 12, because the manufacturer knows that their instrumentation can't withstand pHs over 12. That's a fair and that's a reasonable sort of guidance, but not being non-specific. I mean, some instrument manufacturers can be far too specific, and their guidance ends up not being followed anyway. I mean, going back to Mark Campbell with the Da Vinci instrumentation, he doesn't follow their guidance. They've signed off on his process. So, there are different ways to achieve the same results.
Yeah, I mean, quite often it will come down. Sorry, go on.
Yeah, sorry, go on. All I wanted to say that this is a great example where someone actually found out maybe a way that took them better to achieve a certain result, but he could only implement this particular methodology because he was able to somehow verify the final result. And this is great, because this is what we can actually achieve. And I 100% agree with what Matthew said about the requirements for chemicals. We have to very clearly specify maximum allowable temperatures, because you also have to make sure that the end user knows what type of process to use to clean and then disinfect and sterilize particular instrument. And then having those sort of rough guidelines, you leave quite a lot in terms of the way the process itself is developed to get the process designed for that.
Okay. Well, I'm sure it sounds like there's a good opportunity for the sterile services managers, as I say, working at a local level to try and develop their own protocols. But I think that's sometimes the opinion would be that the instrument manufacturer or the washer disinfector should have a specific answer for each device, but of course that's not the case. But I mean, that's something hopefully we can pick up with future guests on this podcast moving forward.
No, absolutely, and I'm looking forward to picking some brains out.
Okay,
Agreed.
great. Thanks, guys.
Okay.
Thank you very much. All the best.